Hello and welcome to another focus chat. Um, we've tried this once before and I think it was a very interesting chat, and would like to record some more videos around this idea, to have some chats on very specific topics. And I'm Bolboaca, I'm coming to you from the Mozaic Works studios, and today what I have for you is a focus chat about styles of TDD. And to help me in this chat, my partner for this chat is Adi. Welcome, Adi.
Hello, nice to be here.
Alright, so just a quick introduction to why I believe this is an interesting topic now. I've seen like 2 weeks ago a Twitter post that said that somebody is organizing a test-driven development conference, which is something I wouldn't have imagined a few years back, and it's very interesting to me. And I think many people who are doing TDD or say they are doing TDD will find this idea of a TDD conference being kind of weird, because often I've met a lot of developers who believe that they are doing TDD perfectly, and there's only one style and it's their style of doing TDD. And the reason for that is that they are exposed only to a limited amount of information related to that. And I know that you've done some talks in the past on various styles of TDD, and we had a lot of conversations between ourselves and with other people from community, and we had a lot of practice sessions on trying out various styles of TDD, and I think it's interesting to go through a few of them.
Mm-hmm.
So what's your take? What are some of the styles of TDD that you've seen in practice?
To start a bit with the history, in my first style of TDD was probably any programmer started just trying around things, and in my specific context, I was very influenced by the way where you start introducing a stub or a mock, but more like testing state. You just introduce a value and you expect to have another value. This was for bigger or smaller methods. Sometimes in the beginning they were too big and it was difficult to test. So this style, when you start looking just at testing the state, you might call that Chicago school or classicist school. So it's a way where you look at testing more or less the state and not more than that. So you treat everything like, let's say, kind of a function. And you are interested in varying the number of inputs and observing what is the output for that. After a while, I started seeing that, especially on bigger systems, you need also to understand how the interfaces work and to test them together. And of course, there are some situations where you cannot test the state anymore, or you shouldn't test the state anymore, because you go to systems that are very slow or very brittle, like databases or external APIs, where you basically cannot retrieve state, or different framework interfaces that block you from getting the state. So that's why you need to introduce the mock. So you just say, okay, this is the limit of my testable system, and here I stop testing the state and I start using it. So that's how a classicist or your Chicago school TDDer would act. But
And
after a while, I
just
started
to clarify a few things here, because I've often seen a confusion between stubs and mocks.
yes,
And the reason for that is that most tools that we are using today, so just to go back a little, when we started doing unit testing in the industry, we didn't have fancy frameworks for unit testing. And actually my first experience with unit testing was that we had to write our own unit testing library for C++ because there wasn't any at that point. And And many times people were rolling out their own stubs and mocks written by hand. It wasn't something that you would get out of the box from a library. But now most of the libraries that offer stubbing and mocking and that people are using them, they are collectively called mocking libraries. And sometimes they offer a stub as an option there, but it becomes very confusing because you're using a mocking library and sometimes you create stubs, sometimes you create mocks. And these two kind of get together and get mixed by people. And
That's the biggest confusion, I think, with these terms. They are still not clarified, and I guess they won't be clarified for a very long time.
yeah. Well, in my mind, they are quite clear because I mean,
Yeah, I mean in the libraries and
yeah, the libraries made it very confusing.
it's very difficult to say this is a stub and you say create mock. That's what you write, you know, new mock or a kind of a constructor for a mock, but you say okay, but this is a stub. It's not a mock, but you create a mock.
Yeah.
Yeah, so after that, after a while, I started also working with other people who have other experiences, and they would need to look more on the interfaces, and especially this happens when you work a lot in enterprise environments where you need a lot of interfaces, so you integrate a lot. So that's why the other style, or one of the other styles, because they're more in fact, but the mockist approach where you just have mocks, so you just uh, test the collaboration between the interfaces and you don't test state technique. So basically that's different. With a classicist, you look at testing the state, and a mockist would look at testing the collaboration and would use these objects that double what an artificial interface would return. Now, I think there's a good point in calling both of these terms test bubbles, mocks and stubs. So that's my terminology at least, and I think that would bring a lot of benefit.
And yeah, and this terminology is actually quite confusing in the industry and in testing because many people have their own terminology in their own organizations. But if you read Gerald Mezaro's book on unit testing, these are only just two of the possible test doubles that you can use. There are much more of those. So I don't know the exact number, I can't remember, but they are at least 10. So there's still much more that you can do with other types of test doubles as well. But
but sometimes people also call them fake because they say instead of double or mock or stop, they call them fake because it's a kind of a fake part of the system. But in the other terminology, a fake is something totally different. So it's extremely confusing. For me, a fake is just a part of the system that doesn't do that much. And I just use it because I cannot interface with the real stuff. While with the mock, I want to get a fake answer. It's very, let's say, very sensitive, a very fine difference between them, and you really need to experience them for a while to get that.
I've also noticed that some people call mocks when, for example, you have a service or a component and you need to integrate with that component, but that component is built by somebody else. And then you replace that component or that service with something that is a test double, but that replicates the whole interface of that component. So it's like a larger area of integration than just a class. and they call that mock. And this often makes things even more confusing, because then you have mocks on the level of classes and interfaces, and you have mocks on the level of components, and these two are quite different, and so on. But anyway, I think it's enough about the confusing nature of this.
It's just that it's confusing, and I always prefer to explain. Now I will introduce a stub. Look, this is what a stub means. And then I'll go on. So every time I pair or I code with someone or I go to a new team, I explain these concepts, and then we can continue working together, I guess, a lot more efficiently.
Yeah, and our advice is generally for people to figure out what each of the words they are using mean, even if they are using different words in their organization from other organizations.
Exactly.
But, so that's enough about terms. The fundamental idea is that classicist style or Chicago school goes more on data, inputs, outputs. The Mocky school or London school, and I know these terms are a bit also not accepted by everyone, but that's, let's say, the general knowledge about them. The Mocky school goes more towards testing interactions between classes, and each of them has advantages and disadvantages. With the classicist style, you often end up with a lot of getters and setters in your classes, because you need sometimes to set some data in order to test it later and to kind of inject it. They go more with stubs rather than mocks, so replace things based on data and not based on interactions. And with the Mocky school, one disadvantage is that you may end up with tests that verify a lot of interactions without verifying any actual behavior of the that's actually useful for something.
And I guess the biggest critique about this mockist approach is that they double or they replace in a way the implementation. So then it's very difficult to change the implementation, because you need to change all the tests of that layer. And that's bad from two ways. One is that you cannot change both tests and implementation, because you don't know if you'll do something good or not. So you don't have that that safety net. And second is it's a lot of work. It's double the work.
But that's not the only line of variation between the styles of unit testing. There's another one, and that is, where do you start? Do you start from outside in? Do you start from kind of from bottom up, or do you start somewhere in the middle of the system? And so what are some differences here?
Well, I guess typical classicists would start from the bottom, so from the very simple thing. The first test is assert 1 equals 1, and then or something like that. So it's something extremely simple, and then you add one more test and one more test. So let's say you want to test addition. The first thing is that test that 1 plus 2 is 3, and then you'd return a 3, and that's all. The second test is, okay, let's test that 1 plus 3 is 4, then you return, you kind of create a case or an if statements and so on, until you force yourself with the tests that you create the correct function. That's kind of extreme, but this is how you think about it. And so you start from the very small leaf of the code, but that can be from the bottom, also sometimes from the middle of the system. So by that I mean not necessarily from the data layer, which means the bottom, but the middle of the system, which means the business logic, the domain logic, and so on. While the classicist would start typically from the top. So you start creating an interface, so you care a lot about the user, so it's a lot more, let's say, user-centric. And from there you start layer by layer going, down or towards the middle or towards the data layer.
And I think what I like personally, the top-down approach for any application that is user-centric. So if you're doing something like, let's give an example, I don't know, Twitter or Facebook or a CRM or any kind of, or even a online banking system. What you want is to define the interface and the UX and the UI, and it helps if you can start from top and then go little by little to the bottom. On the other hand, if you are doing something that's very algorithmically heavy, like, I don't know, Google search, it makes little sense to start from the interface, because the interface is so simple. It's like, a search bar and go. It's nothing.
Introduce a word.
Yeah.
Or a phrase.
And of course you can make a lot of variations there, but still the point remains that you probably need to look more in the algorithm side of the things rather than in the top. And there is also a difference between if you're doing things like middleware, or you are somewhere in the middle inside of an enterprise between two different organizations. All right, so you have on one hand, I don't know, the banking offices, and below you have the standard banking things, like you have access to accounts and to payments and to all that, and you need to somehow mix those two together or move data from one place to another. Then obviously you are somewhere in the middle, so you need to move around there and to figure out what's the best approach. But then what's even more interesting is that you have a combination of these styles, because you can go top down and be mockist, or you can go top down and be a classicist.
Which doesn't happen that often. You can, but it's a bit weird.
Which one? Top down and classicist, right?
Exactly. Yes.
Yeah. Well, I mean, one way you could do it is by using stubs in the beginning, and then keep replacing stubs with real implementations, and you end up
it's something called fake it until you make it. This is the one where you start faking and continue faking until you make it, until you have something which works really, at least for a very narrow use case.
And then okay, so you can have bottom-up classicist, and I guess that's kind of the typical approach.
Yeah.
But you can also have bottom-up mockist, which is weird, but
very weird, yeah.
it is possible as a style. And then you can start. Yeah, please.
I think that's something also interesting, which started with the domain-driven design community, and the domain-driven design being more and more used, especially in complex domain where it fits really well, where you start with the domain, so from the middle, and then you need to start understanding in those bounded contexts how to write the tests. So in that moment, in the bounded context, you probably write a classicist approach, and the bounded context where it interacts with the other bounded context, then you start having a mockist approach. So that's, I think, probably the best way I know to mix the two and be extremely productive.
Yeah, that's true, and I wanted to point that out as well. That domain-driven design has changed a few things around here, since you're doing some upfront design by figuring out important things about your domain and figuring out what is the, let's say, some anchors, and then you need to feed those together using some kind of TDD style. And yeah, it becomes a bit different from what we are used to. It's not bottom up, it's not top down, it's kind of middle around. You start from that domain, and then I guess you could use both stubs and mocks to do that, right?
Exactly. Yes.
So it can be domain-centric, mockist, starting from middle around domain-centric classicist, and so on.
Mm-hmm.
So there are already like 6 different styles of TDD here, and
At
strangely,
least.
that's not all of them.
Yeah. Yeah, they're not all of them. There's so many approaches, and there's another one that started also from the Gauss book, the guy building. How is it? Building guided objects with tests. I never remember the name of the book, but it's the Gauss book, and so they say that you can have a double loop TDD. In a way, you start with a guiding test, which is kind of a big test from that gets through all the layers, and then this is more or less like a state test, and then following that guiding test, you want to follow that path of the initial big test and start continuing with smaller interface tests or collaboration tests with mocks typically. So this is another approach that can work extremely well, especially in enterprise systems.
Yeah, and those, again, it's a problem of terms. Often those tests would be acceptance tests, or the test that you start from. So if you
Yes.
work in a Scrum-like environment, or if you are using user story, or if you are using at least acceptance tests, then you can write those acceptance tests and automate them. And you start with, let's say you have one user story and it has 5 acceptance tests. You automate them, all of them are read, and then during the sprint or during the iteration, you actually use your TDD to turn those tests green one by one. And this also gives you a measure of progress, how much of the story is done. And it also allows people to figure out during the development that, oh, maybe we missed an acceptance test, so let's write another one. And sometimes it just passes, and sometimes it just adds a bit more of things to do. And it's always good to know these things early. That's one of the powers of feedback cycles in Scrum or XP.
Yeah.
And sometimes, to make things more confusing, those acceptance tests are written as BDD specifications, so behavior-driven development specification.
Yeah.
Which, by the way, many frameworks now, many unit testing frameworks now, allow you to write tests in the style of BDD with given, when, then.
Yes.
Which is somewhat of a variation from arrange act assert. Is the same thing, only said differently. The BDD approach is much more valuable at the high level when you look at and discover all the possible cases.
Yeah. So in a Scrum environment, you could have, let's say, the business or the product owner write the specs in BDD, which are in a language that can be automated, so that then the testers can look and add more edge cases around those initial business tests, and then the programmers would start implementing those on basis of those tests, considering that they are guiding tests, and adding with whatever flavor of TDD, adding small unit tests. And whenever the big business test is green, that means, okay, we've done one of those acceptance criteria. So you don't need ever to think about, have we passed this or not? Do we need to do more testing at the end? Basically, you'd start with the testing, with the acceptance test, and continue with the implementation, which is probably the opposite of what waterfall says.
And it's also quite one thing to bear in mind, though, is that sometimes people use test doubles for the acceptance tests, And then it becomes really confusing because the test is passing, but is not actually testing the real thing, is testing a test double, and it doesn't really work. So
fake it until you make it. Yeah.
You really need to be very careful with how you use that. I think we've all seen and perhaps experienced the situation when we were struggling with a test and realized that we are testing the test double instead of testing the actual thing that was about to test. And when things get so confusing, then something is wrong with how you write, how you organize the code. If you have too many mocks in a test, if you have too many stubs in a test, if you have a combination of stubs and mocks that's no longer understandable, then you have a problem in the way you are testing or in the way the code is structured. But anyway, I think this has given you at least some hints of what different styles of TDD there are, and there are
and how simple it is.
And there are much more variations to this. So once you introduce the double loop, you can have, once again, acceptance tests or behavior-driven things written in different ways, or you can have Selenium tests written on as acceptance tests written as Selenium tests, and then you can go and use your top-down mockist or bottom-up mockist or whatever combination you want inside your code, and you end up with all kinds of possible combinations between these two. And this is before adding things like property-based testing or other,
let's not even get into that.
Other even more variations. So here it is. That's why you need to it's good to practice these different styles. We all have one that we prefer, and we all have one that is kind of the common denominator in the team, and we will use it. But because mixing styles can be very, very weird when you're working in a team. So it's best if all the team works with the same style. But it's still good to experience the different styles to figure out which are the advantages, disadvantages, because often you can steal from one style one little thing and apply it to your own style. And there's no full description of what makes a good TDD style. We don't yet have that. It's still so many variations.
It's too difficult to say. I think you can never say that.
Yeah, so many variations, so many people doing different things. There's a hint of personal style in this as well.
Of course.
There's always some personal variation to it. So it's useful to experience these things. If you think you know everything there is to know about TDD, try experiencing these things and you'll figure out that probably there's much more to learn, because even people who have done this for 20-30 years, they say there's still so much more that I can try and learn.
Yeah, exactly.
All right, thank you so much. Thank you, Adi, for
it was a pleasure
being in this chat. Thank you all for watching. We have to pay our dues to the YouTube algorithm, so please like, share, subscribe, comment, tell other people. Let us know if you find this interesting. Let us know if you would like to learn more about styles of TDD, or about software design, or about any other topics related to software development that we can treat in a focused chat. Thank you so much for watching, and until next time, remember to think, design, and work smart.